Let's take a look at this firewall I hinted about at the end of the last video. It's called a proxy firewall. And what happens when you vote by proxy happens often when a corporation, say, has 100 million shares and you have 1 share or 10 shares. And you have to have a certain number of shares to attend the shareholders meeting, whether that be New York, London, Paris, or Munich. And you don't want the travel expenses anyway if you're not a major shareholder. But what you can do is vote by proxy, which means basically you are signing over your vote to someone else, or you're telling them, hey, I want to vote yes on the first thing that's proposed and no on the second thing. And then they vote for you. They vote in your place. And the reason I bring that up is that that's what a proxy firewall does in a way. It's going to connect to an external destination on behalf of you, the internal host. And it may not even allow you to connect if it detects that there is an issue with said page. And we're going to look at both of those scenarios, when things are fine and then when things are rotten, in just a moment. Because the proxy firewall, it's really our middleman between the network's internal hosts and the destinations outside the network. What do all sales warehouses say? We have these all over the world, but especially here in the States. We have warehouse clubs. We cut out the middleman. Well, where the middleman may bring a little extra cost, sometimes the middleman is not a bad thing. And you can tell that I used to be a middleman in another business when I said that. But the thing is, the middleman here is going to add an extra step or two to the connection, but the middleman brings some benefits. It's all in the name of a secure network. And this is what it's going to look like. You've got your proxy server in the middle, and it's got an interface, of course, in an internal network, and then one going out to the internet. We have an internal host who wants to connect to a web server. And really, it's a 4-step deal now, because previously, of course, the host would have just gone straight out through the router after the internet, gone to whatever web page you wanted to go to, retrieves the page, brings it back, and that's it. Send a request out for a web page, get it back, that's it. But with a proxy server, we're adding a couple of steps. When the internal host sends the request for a web page in step 1, the proxy server really intercepts that. It says, oh, okay, I see what's going on. This internal host wants a page from website X. I will go out and retrieve it for the said internal host. So then the proxy server holds on to the original request from the internal host, and then in step 2 sends a request of its own out to that same web server for that same web page. Web server doesn't care. And by the way, this is transparent to both the web server and the internal host, because the web server doesn't care if there's a proxy server in the middle of it. It just knows that it got a request for a page, and as long as the internal host gets the web page that he or she wanted, that internal host is perfectly happy. So there in step 3, the web server sends the page back, and now the proxy server gets it, looks it up in a little table it keeps, says, oh, okay, here's who requested this page and here's who I need to send it to. But at the same time, the proxy server is going to do a little firewalling. You see the little bitty firewall next to that server, and it's going to inspect that page. And of course, that's very, very configurable. No two proxy servers are alike, but we can configure it to say, here's the kind of thing to look for, here's what not to look for. And in this case, the proxy server looked at it and said, okay, the page looks perfectly fine. I don't detect any issues, any scripts embedded in it, anything like that. So I'm going to send it on to the internal host. Now, when things don't go so well, I brought up the cross-site scripting attack, mainly because I want to keep trying to say XSS instead of CSS. It's really hard not to use CSS for this, but of course that's something else entirely. The cross-site scripting attack, XSS, having been on the wrong end of this more than a decade ago, I was not the senior admin, and when it hit, I was kind of glad I wasn't. What happens is, the proxy server battles this attack, which has a malicious script actually injected into the web pages. It's interesting that the cross-site scripting attack is actually attacking at first the web server, and it's injecting a script, a little piece of code, into a web page when it detects a vulnerability like that. Now, when a non-protected viewer visits the site and gets that infected page, the script is activated and the results range from, and I took this straight from Wikipedia because I just love it, a petty nuisance to a significant security risk. I think you'll agree with me that's quite the wide range, and it depends on the sensitivity of the data handled by the vulnerable site and the nature of any security mitigation implemented by the site's owner. So that is what we call covering all the bases with a definition. But in all seriousness, it could be minor, it could just be somebody having some fun. Nelson Muntz is going to come up on the screen and laugh at you, but more likely it's going to be much more serious. Cross-site scripting attacks are not as numerous as they used to be, but they are still out there. And here's the two-step way it can happen if you don't have a proxy server. Internal host says, hey, I need web page X. And the web server says, here's your page, and a bonus nasty script that someone went ahead and embedded into it. And again, the thing is, the host here, the web server, could be and probably is totally innocent of any wrongdoing. Yes, it could be an inside job, but most likely it was someone external to this external network saying, okay, I've done a recon attack and I found this vulnerability. I'm going to put this code in, and we'll see how it goes, and we'll see who gets it and how they're affected. Now, when we have a proxy server in the middle, the first three steps are pretty much the same as we described earlier. Internal host asks for a page. Proxy server holds the request in step 2, then requests that web page itself. Step 3, the web server gives the copy of the desired web page, and the proxy server gets it and says, wait a minute, this web page is dirty, and I don't mean morally. I mean, it's got a script in it. It's got something embedded in it it shouldn't have, or it's just suspicious for one of many configurable reasons, so I'm going to block it and notify the network admins. Of course, that's an important step, because if it's not notifying us, then we don't know that it happened unless we happen to look in the logs. Now, in this case, your internal host is likely going to get a default screen from the proxy server, and it's just going to say something. You've seen that kind of message likely on the web, something like, oh, this page has been determined dangerous. Contact your network admin at XXX phone number, and then your phone's ringing. But the thing is, the proxy server stops that attack before it gets inside the network. As I've said it before, and I'll say it again, it makes life a lot easier when you can defeat an attack at the perimeter of your network rather than having to repair and fight it once it gets inside. And again, just going over this again, I mentioned it once, but I want to mention it again. There are really two victims here with the XSS attack. You've got the website hosting the script and the host visiting the infected page. And as I mentioned, the script could be put there by someone on the inside who works with a company that has access to that web server. But, what probably happened is our burglar here coming through the internet window did a recon attack, found a vulnerability in that server, and injected the script into it. The attacker also could have found out, hey, chrisbryant.com, which is not my domain, but I just pulled it out of the air. They visit this website a lot, and they're the ones I want to attack, so I'm going to plant a script, not trying to put it directly in their network. I'll put it on this web server, and then they'll retrieve it themselves. So pretty evil stuff there. Now, we're going to take a little bit of a break from the corporate firewall, which is what we're looking at now. And we're going to spend a few minutes on the next video talking about personal firewalls, which, the name again is the recipe, but we've got some good stuff here for you to know for your NA security exam, some good real-world tips for your end users as well using personal firewalls, and that is all coming up next.